So, hello everyone. Welcome to our second online session of the Foundation of Statistics course using R. It looks like that we have about 28 students in this session today, so that's great. I'm going to start by just doing a quick roll call, and I do this just to make sure that your mic is working and everything, and then so we can all interact well in this environment. So I have my chat window open, and I also have my attendee list open. So if for whatever reason you can't use your microphone and I call your name, you can just type your name in the text chat or say, hey, I'm here. Otherwise, I'm going to ask that you just unmute your microphone and just tell me that you're here. So we'll start off real quick. This will take about 4 minutes. If you have your microphone on now, I just ask you to mute it. And when I call your name, just unmute it and just say, hey. So,
yeah.
Charles, are you here? Is Charles here? Okay.
Hello.
Great. Welcome. How about Mitchell Farber? No, not Mitchell. Okay. Shamika.
I'm here.
Okay, welcome. Gary Wright.
I'm here.
Welcome. Bararth. Okay. Bararth, are you here? I don't see you. Okay. Jeff Bevan.
I'm
Great. Jimmy Zhang.
Good morning.
Good morning. Nande.
Good morning, I'm here.
Okay. Oh, Mitchell, thank you. Nande, good morning. Aman Karki.
Good morning. I'm here.
All right. Mark Parsons.
Good morning, everyone.
Okay. Ajay.
I'm here.
Great. Aman.
I'm here. Aman Karki.
Thank you. Kai Wei.
Good morning, everyone. Kevin here.
Terrific. Bharat.
Hi everyone. I'm here.
Good. Thank you. Akshay.
Hi, I'm here.
Thank you. Did I pronounce your name right?
Yes, it's Akshay.
Akshay, thank you. Alexandro.
I am here.
Welcome. Ahmad.
I'm here.
Thank you. Alex Koo.
I'm here.
Okay, Tanique.
I'm here.
Perfect.
Good morning.
Good morning. Nicholas. Nicholas, are you here? Let's see. All right. Moving on. Akash.
Good morning. I'm here.
Okay. Chad Rothbart.
Yes, I'm here.
Okay. Annabelle. Annabelle. Okay. Salma. Oh, Annabelle, you're here. Thank you. Salma, are you here? Kyali. Okay. Albert.
Hi, I'm here.
Okay. Welcome, Albert. David. David Edwards. Here. David Edwards. Okay. Angela.
Hi, good morning.
Good morning. Okay, Tyler.
Good morning, I'm here.
Okay, perfect. We're in the swing of things. That's great. Everybody's mics works. So I hope you're psyched for our second online session. I encourage you to make sure your mic is muted, and if you have questions along the way, feel free to use the text chat. You can also speak up. That's totally acceptable. I see a few other people are here in the text chat. Thank you for that. What we're going to do is I'm just going to give you a rundown, a little bit of the plan for today, and I want to make sure that you have the materials that you need for today, and you can go to the materials tab in your go to training control panel, or again, they're always on NYU classes. So if you have a question about that, you can ask in the text chat. I encourage others to help each other answer questions. We have a very large group today, so it looks like 30 actually. So I'm going to do my best to get to everybody's question, but hey, if you know the answer, why not? And I know that there are some R experts in our class. There are a lot of novices. There are a lot of people kind of in between, and there are a few people that have that are experts. So please, whatever level you are, if you know the answer to the question and you can help somebody out, please feel free to do that. So as you know, that these online meetings are really meant to give you an opportunity to practice and to help you along the way to build on your prior knowledge, whether it's prior knowledge of like programming in general, or based on previous lessons that you've taken in R as part of this course, and to give you an opportunity to ask questions and get answers to those questions in kind of a quick, productive way. Sometimes email can be a long way, but know that I have an awesome teaching fellow for this course. Katie Walker. Hopefully some of you had a chance to interact with her. So she's been monitoring our discussion forum in NYU classes. If you go to NYU classes, our course, there's a tab called forum. You can go there and ask questions, and she's really responsive to that. And that's also a nice place for you to help others too. In addition, feel free to email myself and Katie if you do have questions. Sometimes she can be a little bit more responsive, or I might be a little bit more responsive depending on our schedules. So it's good to sometimes email both of us. Great. If you're not getting a response to a question, then send it again. Okay. So it's not out of neglect. It might just be that, we're getting a lot. So that's all. If you're not getting an answer, definitely circle back and want to make sure that you're getting the help that you need. I haven't heard any negative feedback, but just want to put that out there just in case you're not getting the help that you need. Okay, so this session corresponds directly to the third lesson in NYU classes for the R section of this course, and we're going to review a few things. We're going to review working with packages, importing data, and writing R scripts. And this is really kind of taking you to the next level. Like the first two lessons, you're getting familiar with R, you're in RStudio, using R as a calculator, and doing some really, really basic things to allow you to gain some proficiency, and probably a lot of typing and retyping. And so now you'll be working on creating scripts, and now you'll be doing a lot more editing than just typing alone, which I think you'll find very useful. So I want to start with talking about packages. So I'm going to, throughout today's session, I'm just going to ask you some questions and expect that some of you will answer in the text chat. So one of the questions I'll throw out is, what is a package? Okay, a collection of functions, other scripts, a bit of code which does stuff to data, stored procedures, a library of previously compiled code, portfolio, right? So these are good. This is good. A library. So we can consider it a library. We can think about packages as basically what you see here, a compilation of functions that are available for us to perform operations on objects. And objects in our case might be data, for instance. And there are many, many different packages, as you know, in R that are available for us to use. So let's say, I'll give you a real life scenario. So right now I'm working on writing a linear program. And my linear program, the idea is that I want to minimize costs. Okay, so I'm using an optimization technique to minimize costs. of shipping products from, a factory from several factories to several customers. And I want to figure out the best how to optimize my model and have the lowest cost. And so I say, well, how do I do that? Well, I actually need a package that's going to have a linear programming model built into it. Okay. And in order to create my model. And that's a kind of a use case. Now we have many packages that we use for visualization, for instance, as well. So you can think of your packages as like toolkits that do specific things, and those toolkits contain a variety of functions, and those functions operate on objects essentially. So hopefully that was a good explanation for you. When we're installing packages, there's some things to think about. What I'm showing you here is just the zoom in on RStudio, where you see anything that looks like a hyperlink here. That's the package name. And if there's a check next to it, that means that package is enabled for our use. And I'm just going to mute everybody because I'm hearing a little bit of background noise. Okay, I'm just reading a few things in the text chat. Apologize for my pause. So anything that is checked means that is enabled for use as you are working in RStudio. If it's not, and you try to use, let's say, this GG themes here, and you try to call a function within GG themes, guess what? What's going to happen? That's a question. You're going to get an error. What kind of error? Well, I'm not going to be able to use, I'm not going to be able to use that, any function that's part of GG themes, unless I do what? I could check the box, right? Or I could say, require parens GG themes. It's already installed, so I'm not going to want to install it. I could say library GG themes, good Akash. I could say require GG themes. Those are a few things that I can do. Or I could literally check the box. I'm not going to have to install it because if it's listed here, that means that I already have it installed. Okay, but for some of you, if you've gone to, say session 5, for instance, and you're dealing with creating visualizations, you might not even have ggplot in your packages. So you should check right now, see what you have. If you didn't have ggplot2, what I'm highlighting, kind of like mousing over here, you'd actually have to install that in order to use the various functions that come from ggplot2. Okay. You can also see a nice description, or sometimes a not so nice description of what these packages mean. So a package are a series of functions that are available under a very simple name like ggplot or foreign or whatever is here. And know that many packages, according to many R experts, this is like more of an opinion, but including Hadley Wickham, I've been reading a lot of his work, and he's the one that really oversees a lot of the development for RStudio and ggplot2 and Tidy Data. If anybody's familiar with any of that, it does a lot of writing and creation of packages and libraries and things like that, and is a real leader in the R community. One thing that he says is that a lot of these packages that are available are really not developed by programmers. They're developed by people who needed to solve a problem and then shared their solutions in terms of a package with the world, with the R community, and we can use them, which is terrific. However, if you think about it, some of the programs may and functions may not work so well because maybe some of them aren't created by programmers, but by people who needed to solve a problem. This is not this is just like an opinion, and it's not every single package. It just might be a few. If there's some esoteric ones that you kind of like found somewhere, you kind of want to check the validity and the reputation of that person who might have created it, because they could do some weird things. Okay, so let's move on. And this is a general description of what a package is. And to see which ones are in your version of R, you can just type library, right? The library function here. The second thing that I wanted to just go over with you is importing data. So there's a few things. How many people have had trouble importing data in R? Anyone? It's okay to say yes if you have, because that would be good for me to know. Yeah, so what are some basic problems that we have? Getting random characters in the data. So your data might not be that clean. Okay. Right. So that's pretty common. There's a few reasons for why that some people had to clean things by hand, right? That's like terrible. But sometimes that is the reality of when we're working with data, that it's not always going to be like perfect for us. And perfect data means that we're living in a perfect world, and data is generally representing some phenomena that exists in the real world and encoded into, numbers and letters and words and descriptions and all of that. And sometimes that data might even be encoded incorrectly, or, like over, it might be just decoded incorrectly. So some of you had to do a little bit of work, I think, cleaning it. That's not always going to be the case. In this class, you will get some nice clean data. So that's like a first lesson. A second thing is, when you work in R, there's a couple ways to read in data. One is using a function called read.csv, and there's another one called read_CSV. Does anybody know the difference between the two? Okay. Data size. Yeah, so the key difference that I wanted to, I think, which Akash answered, is that the read.csv reads in a data structure called a data frame, and the read_CSV function, reads in a tibble. And these are different data structures. And if you remember from our first online meeting, we talked a little bit about data types and data structures. And we always want to kind of be really familiar with what structure our data is in, whether it's just a single variable that we create, or whether it is, an entire data set, right, that has a structure and a type. And that's really important because why? Well, I'll answer that question for you, because we are working with packages that have a series of functions, and those functions can be performed on certain types of data. And if our data is not in the right form, we can't use certain functions, which limits our ability to take advantage of, say, some of the packages that are available in R. So luckily, we have ways to convert our data from one format to another pretty easily. But I want to clarify that there are differences between these two functions. And the read.csv is actually a pretty new function that is available. It's just in its version 1.0. And there are still some things that are being worked out with it. Again, they come from different libraries or different packages. Read.csv has been around for a while. It's part of the utilities package, UTILS, where library comes from the read_r. Okay. And when we use read CSV, in this case, it imports our data as a data frame, data structure, and you can always use the class function to verify that. And if we use the read_r library, our data will be imported as a tibble, a simple data frame, and we can use the class function to verify. So that's just a little bit of information there. There's other functions, like I think Akash is saying, oh, there's a read CSV2 that also comes from the util function, and there's many, many others. You're not only going to be reading CSV files in, you'll be reading many other file types, maybe like Excel files and others. So there are a lot of functions that can help you read in other file types. And we start with the most simplest one, CSV, and we'll build on that. Right. So Charles, you're correct. So when you import a read_CSV and do a class, you get a response like this TBL or like this tibble object. So I recommend that you use read.csv for purposes of like this course and building on that, because a lot of the functions that we're going to be using operate on data frames, not necessarily tibbles. And over using the read_CSV. And so we would simply read in our data like it's listed here on the left-hand side of the screen, where if we're using like the Winter Olympics CSV file or anything, we pass in the name of our file and then two other parameters, that it's a comma delimited file by using the SEP parameter, and then there's a header. What does the header mean? Okay, so it's a column. It means that there's column names, okay? And we want to read those in. Good. If I didn't say header true, it would treat the first row as data, not as headers, and then it would create its own headers. So that would be kind of messy, okay? So you can try that out, or put header equals false and see what happens. So maybe we'll even do that just as a test, just so you can see that. The third thing that I want to go over is R scripts. So there's many advantages of writing scripts as opposed to writing code at the command prompt. And it's listed here and it's pretty obvious, but by being able to create a script or a document, you can save your work, right? So imagine if you're writing, what was the worst thing that about using, say, a typewriter, like in the past, right? Like it was hard, it was really hard to go back and edit. And nothing was really saved for you, and you couldn't go back and, edit without using whiteout or something. So here you have a script and you can save your work, and everything is digital. In both cases, and if you're not using R scripts, you can go back in your history, but it's not as robust, and you can't think about planning out a whole program when you can't save it as a script that you can just run. You can reuse your code, say from one project to another. You can document your work. I mean, you can even create your own packages that maybe you use. So you can write your own functions that do really helper functions that do really cool things for you. We'll learn how to write functions in the face-to-face class, so that can help us do things that might be handy. And it allows us to share our work with others when we can write it in a script. And obviously the last point, you go beyond writing one line at a time. So this should be, for those of you new to this, a relief that this is available. And to create an R script, it's pretty straightforward, and we will go over that. I just have it written here just so you have the notes on it. And then finally, I just want to introduce you to some of the practice exercises for today. So if you, we're going to be using the session 3 exercise, session 3 practice exercise, and we have a few data sets. We have a March Madness CSV, and we have a Winter Olympic CSV file that we'll be using. And we're going to be doing a few things with that as listed below. Again, this is supposed to be practice, so for those of you who are like, I know how to do this already, good. An opportunity to practice. For those of you that this is completely new, well, it might be an opportunity for you to learn it, and then you can go back to the lessons. So again, if I'm going too slow or too fast, please let me know. You can do that by sending me a public chat or a private chat. Either one. I appreciate the feedback because, again, this is your time and your class, so I want to make it as useful as possible. So why don't you go ahead and open up the PDF file, the session 3 practice exercise, and make sure that you have all your data in the right place. And I'm going to navigate to my RStudio window. Okay, and you can see that I'm working on a lot of different things here. And we're going to start by looking at the session 3 exercise. And what I like to do, since I've been working on a lot of different programs, working on some graphing here, all that, I like to look at my global environment here, and I like to just use the room here to clear all my objects from my workspace. So I am starting fresh. And then I'm going to go ahead and start by also saying Control L to clear my console. So that's nice and clean for you. You can see that. And then finally, I'm going to begin by going ahead and creating a new R script. And so I have some data. I have a script that's like written out for you on page 1 of the session 3. And I just want to start by having everybody create an R script. So simply you'd say File, New File, R script. A few things I want you to do before you save that. Now you'll see mine says Untitled. I'm on line 1. Really important is that to set your working directory so you know in your script knows where to find any of your data files and anything that you're going to be referencing. And so there's a few ways to do that. So the way where you don't really have to like memorize how to do that is to say session, set working directory, and then choose your working directory. This should be the directory where your .csv files live and where you want your .r scripts to live. And if you remember, I kind of asked everybody in earlier lessons to have a folder on your desktop called like My Data. Again, you could put it anywhere you want, but just make sure that you have that specified. So I have mine, and this is just handy. You may want to do the same. Point to my Dropbox. And I have all my scripts and files here for this class. And I do that just because it's very, very convenient. And if I switch from one machine to another, my files aren't stored locally. I find it very, very efficient to do it this way. So my directory is already set to that, but I'm going to go ahead and do it anyway and say, and you'll notice that right here I get this line set working directory, and I just cut and paste that and I put it in my R script. And the reason why I do that is simply so I know that it's set, and I can even run that, set my working directory, and I can put a comment here and say setting okay, recommend that you use comments to comment your work, to remind yourself what you've done and what the code below it means. And I give myself a little space on top. So that should be straightforward. Make sure you have your working directory set. Now you notice it says untitled here. Once I say save, file, save as, it will automatically navigate to my working directory to save, so I don't have to then do that navigation. And I'll call this, my R script 3. And the reason why is because this is the third time I'm doing this. Okay. So everybody should be at that point. Again, if I'm going too fast, please let me know. If I'm going too slow. So after you've done that, the next thing you can do is, begin adding some details about your document, just using the comments. Something like, I like to use the create little indices in my document, and you can do that by having 4 hashtags after any line of comments. So I might just say this is like, if I said something like, part 1, you'll see that now I can navigate between this chunk of code and this chunk of code, which is not much here, but just so you see how that kind of works, it's handy later on in organizing. So part 1, we're setting our working directory. And then the next thing is, obviously, is to import your data. Now, I mentioned that we want to use read.csv. If we use this import data set here, this button, it's going to import from the read R library, and it's also not going to be written up as part of our R script because we're using the GUI, the graphical interface, to do these things. So we actually need to type it out when we're using an R script. So quite simply, you would just want to use the, if you're using whatever you want your data set to be named. I use data just for purposes of teaching. Data is not a good name for a data set. So you should name yours something meaningful. I just do it so everybody is familiar with that I'm referencing the data. Okay. So you can go ahead and bring in your data. And I'm going to say header equals false because I want to show you what I mean by that. What R does when you say header equals false. So I'm going to go ahead and run that line of code. Now, if I go ahead and look at my data, I can say in my script view data, right? I could run that. If everybody looks at my screen right now, you see that the first line was actually imported the column titles, which is annoying, right? And then I have R actually assigns its own column headings for me. So if I wanted to reference rank, I'd actually have to use V1, and then I have to omit this first row. It can be very, so it's always good to look at your data after you import it to make sure that you did it right. So I'm going to go ahead and go back to my R script, which I have a lot of them open here. Okay, so I think I called this my third R script here, and say, of course, header equals true. Now I can view my data, and beautiful. It came in as I wanted it to. Good. Hope everybody's following along. I'm going to go back to my script. And do you notice this view command? This is a command that only works essentially in RStudio. And the reason why I'm mentioning this is if some people have had problems creating a R Markdown document or compiling their notebook, it is because of this. If you have you're using the view function, this is something that's available in RStudio. However, it throws an error when you try to compile an R script. So let's say that I'm here and I want to show you the error that it throws, so then you're familiar. So I say compile notebook, right? And I say I want it to be HTML. I compile it. Everything's going well, and then I'm getting this error. All right, so checking for this X quartz, okay, which is like a viewer that allows us to view this data when we use the view data command or function. So, for instance, when I run view data, this is what I get. However, I'm getting that error in my R. So when I'm trying to compile my notebook. So you can comment that out. So we can use comments as a way to have code that will be ignored by and not executed. Okay. And so now if I went ahead and said compile notebook, I could choose any format that I want. Recommend HTML or Microsoft Word. If you want to do PDF, you need some additional LaTeX libraries, and it's a little bit more complicated. So I would suggest either HTML or Word. Say compile, and now you see that I have my beautiful, simple R script. And I have that line commented out. Okay, so I'm just going to take any questions at this point. Oh, what is R Markdown? Well, Charles, you might not have worked on session 3 yet, but I have session 3 is one of the longer lessons, and it allows us to create RMD documents, and those are called R Markdown documents that are formatted very nicely and allow us to format our code and how the output is displayed. So we have the ability to not only, this is just an R script that is now published or will be published as an HTML file online that I can give you a URL for. So I can show you how I'm doing that if I go publish, and then I will get to your R Markdown question. Go here. I use RPubs for everything that I create for you. And I have to log in. You could just create a free account if you want to. And then I can call this like sample document. I have so much junk in here. So, because I keep doing these demos. And then I get a nice live URL. And I'm pasting that in. Everybody can go ahead and look at that. That's what I really like about RPubs. It's really seamless as part of the RStudio environment and free. Of course, all your scripts are public though, so you may not want that. R Markdown, so I'm just going to get out of the browser window here. R Markdown is a way for us to also include input and output. So, for instance, if I in my script, if I wanted to, say names data, which is the next thing that we're working on, and then run that line. Oops, I have a typo. Happens. Okay, and that's considered output. And then if I wanted to create an R Markdown document, then I would see that output as part of the Markdown, not just the code, which is what an R script and when you compile a notebook, but when I actually create an R Markdown document, it shows the input and the output. Okay, so I would take a look at session 3 for some examples of that, and then I actually ask you to do that. I won't do that right now because I want to make sure that we have enough time to finish session 3. But good questions, good questions. So let's go ahead and move on to the next part. So we've already viewed our data. We've looked at the names of the columns. Maybe we're looking at like how many rows and columns are in the data set. We can use that dim function for that. Okay, so you can try that. And notice when I press enter, nothing happens in my R script. I always have to kind of run that, okay? And then you have the opportunity to finish this out with just a few more examples. So taking the mean of your different types of metals, gold, silver, and bronze. And then, so why don't we go ahead and do that? And Bharath, I'm going to answer your question now. Your question is how to import a text files. There's no choice in the dropdown to import data set. So this is one of the limitations of your of RStudio. So RStudio used to allow you to import text, and because it was using the utils package, now this button now basically is using the read R package and does not have that option listed. So if it's a .txt, then you need to use the other package. So data is loaded in full in RStudio, and it's loaded in memory. And so we can have, if we're working with a lot of data, 5 gigs or something, then we might have some problems with our memory. And that's where we might want to choose a solution that might be a distributed solution if we're working with that much data. If we're working with about under 2 gig, then you'll be pretty safe working with that in memory. Okay, on your machine, depending on the specifications of that machine. So Kai, I hope that answered your question, and Bharath, I hope that answered your question. Okay, so let's go ahead and finish out our script by taking the mean, and I'm going a little slower today because I've been asked, I think by some of you to go a little slower. So I have this script already written, but I'm just kind of typing it out with you, and you have all the answers in front of you for this one. So there's not much thinking here. I just want you to get familiar with working with R script. And don't forget to put your comments in here. Okay, just answering a few questions in the text chat. So hopefully you had a chance to do this. And then you can run a chunk of code by highlighting it and then pressing run. Okay, I probably have a typo here. Sliver instead of silver, right? Okay. So I'm just going to pause here for a second and save my file and also show good, thank you for some people are sharing their work with me. I appreciate that. I'm going to show you how you can take your R script and actually run it. Okay, so now I have some things that are actually happening here. And what I may want to do is run my whole script at once. Now I have two ways I can essentially do that. I can highlight everything and then press run. Okay. And we see the output happening in the console window in addition to any comments that I have written. Okay. Or I can do something else. How would I run my whole script at once? What command would I use at the command prompt to do that? What function would I use if I was to type a function? Ah, great. So specifically what I type, Aman. So source. So what I'm asking is, okay, I'm here. What do I want to type? The name of the script. And the name of the script using quotes. Okay, and the name of my script is my R script 3.R. And then I could run that. I don't see anything that came out, right? I don't see any output. So that's not going to get me that. I need to have echo equals true, right? So you can try that for yourself too. You definitely have to make sure that your script is in your working directory for sure. So you can go ahead and try that. And I will as well. And you see, as I try to type echo out, it gives me, I can actually say echo equals true. And there you go. Good. So a few ways to do things. I'm just going to go ahead and save my script. Let's go ahead and continue. So you see that even though this exercise is straightforward, I had all the answers out, we start talking about other aspects about writing an R script that are important. So it's much more beyond just typing out kind of what's in front of you, but understanding kind of the interplay between RStudio and when you have an R script. And in a sense, you're not using many of the buttons that are available in RStudio when you write a script, like importing the data set or the run button, etc. Okay, because the idea is that this is going to kind of run independent of you. But as you're kind of coding and learning at the same time, it's great to be able to see the interplay between the input and the output. Good. So let's go ahead and finish with the next question. How many of each of the 3 types of metals were awarded, and that's where we're going to summarize or take a sum of our columns. Okay, so you're going to use the sum function, and then data gold. And what I love, R scripts are great, right? Because I can copy this and paste it, and then just change the name of the variable. This time I'll spell silver right. And I can run that chunk. Great, getting the sum. Again, that output would not happen unless I said echo equals true if I was running this as a whole script. Good, thank you for sharing your work. Good habits here. And next we're going to look at a list of countries that did not win each of the 3 medals. So how would we do that? This is where I'm going to ask you to use a subset function. And we're going to use a logical operator. So we're going to evaluate whether or not a particular country did not win a gold, silver, or bronze medal. So we're going to use the OR operator. Who knows what the OR operator is? You can type it in the text chat. Okay, good. So, and I have the solution there for you, but I want you to think about it as you kind of type it in to see what is happening, and I will do the same. So, and when I use the subset function, I mean, you don't have to be as literal as I do, but I actually say x equals data, and then you can use subset. If you want to, a few different ways that you can go about doing this. But I'm basically saying where my condition is basically where gold equals 0. I use the pipe for the OR operator, or silver equals 0. And then again, or bronze double equals 0. So I'm using the double equals to denote equality. And then I need that paren at the end. But I'm being very literal here by saying x equals data. I can get rid of that if I want to. But if you view the documentation on the subset function, you'll see that the first parameter is x, and when you work with the parameters, you can actually you could say select. These are all the different arguments that method takes or function. So you can put those in literally or not. Good. So, and you'll also notice that when I reference the variables, I'm just referencing them by referencing the variable. I'm not saying data $gold. I could do that, but because it's asking already for the data frame, I don't need to add that part of it, which is kind of cool. Save you a little typing. So you can also, and then you can return the results of that by simply typing in metal subset. Or going over to RStudio and double clicking on this, and then you can see the results, which is a nice way to do that. Okay. And when we see the results, we should see a 0 in one of the 3 columns here. So, because that's what we were asking for. We wanted to know those countries that didn't have a medal in each column. So now we're gonna move on to the actual exercise that I didn't provide the solutions for. So I want you to take some time to work on that on your own. Create a new, so I'm on the second page of session 3 exercise. And what I'd like you to do for the next about 15 minutes, we'll see, unless you tell me that you're done, and then we'll move on faster. But we're using a data set from the NCAA, and this is a March Madness data set. So it's about teams in the March Madness playoffs. And it is from 2014. So if you want to use the newer version, you can do that. And that's why I just keep using the 2014 one, because I like to encourage people to kind of download and try this interrogating in the way that I've laid out with the new data. But I'll use the 2014 for purposes here. And the steps are very, very simple. Once you get to number 1 is like set your working directory. Like every time you create an R script, make sure you have your working directory set and you include that line. It's just going to help you later on when you go back to that script, because then that script's you're going to say, where's that data that's supposed to be associated with that script? So making sure that you have that. Import your March Madness CSV file. Look at the data. Look at the number of rows and columns. And then I want you to change the column names to lowercase, because they're all in uppercase as a default. And then I want you to explore the variable data types using the structure function, the str function. So that's part 7. So, this part will take you maybe no more than 5 minutes, right? Questions 1 through 7. And then I want you to tell me how many different conferences there are. And finally, question 9, which is the longer one. So I want you to look at the difference in values between the first 2 columns, okay? And I want you to compute a new vector called DIFF, or difference. You can name it anything you want. And I want you to calculate the difference between the first and second column, which is the first column is called rank, the second one is previous. So what's the team's rank now, and what was its previous rank? And I want you to print out a list, an account of the schools that changed more than 3 places. Okay, so let me know if there are any questions about that. And I will, I see some people have questions about other things, but it's on my clock, it's 11. So we will go over this the latest at 11:15. So I'm going to just give you some time to think about this, focus, and get to work. Again, question 9 is really the hardest part of all of this. And Albert and Akash, I see that you're getting errors for setting your working directory multiple times in a session. That's fine. You don't have to run that part of the code. I just wanted to instill the practice of making sure that you include that in there. You could even just include it as a comment if it's always set for your session. Okay. So I'm just going to mute myself until I get questions, and we'll return in 15 minutes. Just checking in. You have another 10 minutes or so, but I'm on the chat if you have questions. Thanks. I'm getting some great questions in the chat. Some are private, some are for everyone to see, but just let me let you know that I'm actively answering them. I'm just answering a few more questions. Okay, so where we are is that we are working on our session 3 exercise and on page 2. And I gave everybody about 15 minutes to work on that. Does anybody need more time? Please let me know. Let's wait for a response. Tanique wants to know if his answer is correct. So why don't we go over it? So first things first, I have all this done in my R script, so I worked hard on doing this before. So I'm going to go ahead and import my data. Okay. Let's take a look at our data set by using the view command. And so what we want to do is let's just look at it real quick. We essentially want to compute the difference between rank and previous. And if it's changed 3 places, and that really means plus or minus 3 places. Okay, so there might be some errors in some of the code that I saw because you might have just been looking in a positive direction, but possibly not a negative direction. So you want to take the absolute value, okay, of the difference. And then add a 10th column here called DIFF, okay, to your data frame. So just a few things with that. Let's go back to the code. Okay, so we're going to get our column names or our variable names, and we see that they're all uppercase. I'm going to ask you to use the toLower function to quite simply change the names of the columns to lowercase so they're easier to manage. So after I do this, are my column titles changed? Yes. Are they changed in my CSV file? Good. So knowing that, what if I wanted to actually update my CSV file with the lowercase column names? Could I do that? I'd have to use a command called write.csv. So that's we won't do that now, but if you did want to learn how to do that, go to write.csv here, and down below you'll see some examples of how to do that. So those of you that are moving along pretty fast, you can go ahead and try implementing the model for the code here to write out your own CSV file for the March Madness dataset. But I want to make sure that we get through all of this first. Next thing I want you to do is go ahead and check those variable names, make sure that the toUp, toLower worked. Okay, and so I'm looking at using the structure function, and I'm seeing I have a data frame with 349 observations of 9 variables, and you can see those variable names are all in lowercase. And now I want you to create a subset where you show the difference in rankings is greater than or equal to 3. So some people use just the greater than sign. Some people said greater than or equal. So greater than or equal is what we want to use. And you want to take the absolute value. But I'm moving a little ahead of myself. So to take first, what we want to do is we want to subtract the rank variable from the previous variable. Okay, so and then we want to store that in a new variable called difference, and we want to add that to our March Madness data frame. And so we just simply do that by acting as if that vector already existed in our data frame called difference, and by just creating it in one. Okay, so that's pretty simple. We'll run that, and I just want us to take a look at over here our March Madness, and we see 10 variables now. So if I view it, you see that I have my 10th variable, which is difference. And you see the difference is, you know, I see negative and positive values, which if you took a look at that, then you would know that you need to take the absolute value to show if you want it, if it's changed, if it's greater than 3 places, if that's how you code it. So I'm going to go back to session 3. And so here, what I have highlighted, we're going to take the subset from our March Madness data set, and we're going to look at the absolute value of the difference variable greater than or equal to 3. I run that, I can get the dimensions of my subset, and then I can print that out for everyone to see. And since I just took the absolute value, I can see whether the change has been positive or negative, greater than or equal to 3. Great. So any questions? I'm just looking at some private chats that I have. Okay. So if there's no questions, I encourage you, for those that want to, you know, I would encourage you to go to the source for the NCAA and download the latest March Madness data set and then try this out again and see how your data has changed. Another challenge for you is to actually write out the CSV file using the write.csv. So those are some things that you can work on. And then what I want to do is I just want to move on to the 4th session exercise, where we're going back and working with the Winter Olympics.csv file. And I'm just reading through what I want you to do. So this is just some practice with some basic descriptive statistics. And we've already done a lot of work with this data set. So getting to know the data is probably already done for you, but you can go ahead and look at sorting the data. You can look at the data using a describe function. You can take some summary statistics of that, and we've done that a little bit already. And then you can take that to a different level by taking a subset and some computations on that subset, and then finally doing some simple correlations using the COR function. So I'm going to leave you with that challenge to work on for today. We have only 4 minutes left in the session, but for those of you who want to just have some more practice exercises, this is, I always have more exercises than we have time, obviously, so you have some things you can work on your own. So at this point, I will take questions. If there are any. Okay, I see some questions. I see your questions. I'm not sure why you're getting a different dimensions. Maybe it's just how the data has been subsetted or your conditions. Linda, you're asking for a recap on things to know about importing data. So, I mean, just some simple things. A recap for that, I can do that, Linda. And Shamika is asking, where do I get the latest March Madness? So if you look at the PDF file, there is a URL there that I posted in it. So it's under where it says exercises. It says we will be using basketball data for this exercise. And then it says source. And then on that page, you can go ahead and download the latest March Madness. Shamika, back to Linda's questions. What are some recaps of top things to know about importing data? Great question. So first, that you want to make sure that your data is located in your working directory, okay? And you want to make sure that that in your R script that you reference that working directory. And if for purposes of some of the lessons that we're working on, that we're using the read.csv function from the utils package. And we will get to using other types of functions to read in data as we get more sophisticated. But we need to kind of build on first using the read.csv, and then we can understand better how to use the read_CSV functions that bring in our data as a different data type and data structure, which doesn't allow us to do some things that we might want to do as we're learning all of this. So I hope that's a suitable recap. So we're always using the read.csv function for reading in our CSV files for purposes of the exercises in the pre-module. And that should be, make sure that you're reading in as your data, make sure that you know that it's comma delimited, that it has a header for the column names. Any other questions? Kai, I see your question about the kurtosis, and this speaks to, we have many different packages, and sometimes the results of different functions give us different unexpected results, and that's where we have to go ahead and investigate those functions and see what they're actually doing. There's a question on exercise 4. You could use the sum function. You could also do, if you wanted to, for that. Okay, well, I hope this was useful. I did go a little slower than I did in the first session, and know that in sessions in your last online meeting, there'll be 2 additional exercises for you to work on, and looking forward to seeing you then. Some of you might be attending the one that starts at 12:30, so that's great. If not, I will see you then probably online next week. So thanks again, and I'm going to go ahead and stop the recording.